Welcome everybody. In this video I'm going to be showing the off-gridders, something you can do to reclaim your power. I know what it's like living off-grid. You can't use too much at one time. It's sort of a big issue. The more power you intend to draw, the less likely you are to be able to afford the necessary tools that allow that. Like the inverter becomes more expensive, the batteries need to be bigger, the cabling needs to be bigger, everything just starts to get out of control very quickly, so you end up going another route. So for me, that was unacceptable. I decided that I needed to find a better way to protect my off-grid system when I was living off-grid. So things like electric kettles were usually out of the question. You didn't use them. This one here, it will use just over 2,000 watts. So we've got our little meter there, and we're going to flick this on. I'm just going to do a quick demo. We're not going to boil them to their full extent. You just have to take my word that they do work. There are variances in time. If you run it off the mains, and you'll see the difference in power usage, which explains that difference in time. So, but as I said, it's more important to drain less over a long time than a lot over a short time when you're off grid. And yeah, so I'll show another example towards the end of this video with something other than a kettle. But so the kettle's got the minimum amount of water in it, and we're just going to fire that up and see how much that uses. So that's 2042, 34. It'll vary as the resistance of that element changes, but you can hear and see that the kettle is functioning as normal kettles do. And I was made aware, I'll just turn that off, I was made aware by my eldest daughter when I was playing with this, doing research, this induction cooker. I was doing research on anti-gravity, and she came out, and I was using the kettle as a load. These things require a load to keep the magnetic field engaged. And then I was experimenting the anti-gravity. I know some people don't like that word, and look, I question the whole term gravity to begin with. So if, in my book, if something's able to defy the forces of gravity as we currently are mistaught, then that is in opposition to our current understanding of gravity. So it defies gravity and goes the opposite way. That's anti. So, we can debate that until the cows come home. But I was, getting back to the story, I was doing the experiments on anti-gravity, dielectric propulsion, all those, whatever you want to call it. And my daughter said, "What are you doing, making a kettle for the Americans?" And I was like, What do you mean, making a kettle for the Americans? And she said that, well, they don't have kettles. I'm like, what do you mean they don't have kettles? And then the penny dropped. I'm like, yeah, okay, the voltage dropped. And now you're starting to see, apparently, when I looked it up, this was years ago, but apparently back then that they were starting to emerge into the market. But obviously with half the voltage, you get an increase in the amperage. Excuse me. I'll try and block that cough out in editing. But sorry, I can't get the rooster out though. Yeah, so it wasn't really practical, but people on the 110-volt system could certainly do this sort of thing. You could purchase a kettle, and this is a 240-volt kettle, and as you just saw, it pulls a whack of power when run from the mains. So if you were to purchase one of these induction cookers, which is just a ZVS switching unit inside with a fan to keep everything cool, and a magnetic induction, quite possibly a reed switch mechanism in there that is activated by a pot. You place your pot. You're not meant to have a coil on there for normal operation. Normal operation just involves putting a normal cooking pot on there, and whatever you want to cook. Water is just water in that one for now. But the pot is necessary to trigger the device to start magnetically inducing power into the pot. And what I chose to do was use a pancake coil, Tesla pancake coil, because I knew inside here, even though there's a ZVS in there, there's a pancake coil in there. And that's how this thing functions. If you get your own ZVS and connect it to this pancake coil, and you'll need capacitors and whatnot as well, but then that coil there would function in the same way that the induction cooker is. You could place a pot on that, and that would also start to heat up a pot. But the amount of R&D that's gone into these induction cookers, because they have to be used regularly to cook people's food, and people get a bit pissy when their meals don't turn up. So that's reliable and therefore mass produced, and therefore a little bit cheaper. You could spend easily $100 by the time you got all the things you needed to recreate what's conveniently available retail as the induction cooker. I only paid $50 Australian for that one, so that's bugger all. And then when you understand that, now you would just assume that this coil will therefore heat up, but it doesn't work like that. We still need the pot just to engage the circuit inside, and then once it has detected a load, it will continue to power the coil up and run whatever load is. The load can be, you can use lighting. Now it has to be, so this is where the warning comes in. It must be a resistive load. It can't be anything with electronics in it. Now this kettle is a very, very basic, and look, it does have, but again, it has a resistor for an LED just for that light to work. Other than that, there's no real electrical components inside that that can get damaged. And if you were to connect that to a more expensive kettle, that had lights and whatever else, some of them get pretty fancy, you might be risking it. I would buy the cheapest kettle you can, and if you feel comfortable, move up from there. But I'll make a note that it does take longer on this system, but I'll connect this up now and show you. I just had a flashback of my wife going, I need to go to work and my coffee's not ready, and I don't care about your experiment. Put it back the way it was. So unfortunately this was taken back to the study, and my experiments sort of slowed down a little with that one when I was no longer allowed to use the kitchen kettle. But all right, so I'll stop this here, and I'll connect this up, and then show you the difference in wattage use. Okay, so we've got the kettle sorry, the induction cooker plugged into the meter there. It's reading 2 watts just to run that, and those meters are great for that. You can plug them into the wall in your house and plug any appliance you want in it and just see what's going on, you know, when you're not using it. A lot of these TVs today will have a ridiculous amount of power usage when they're off, just in standby mode. They can, now this might sound stupid, but some of them can draw up to 70% of their power rating when they're off. So if you're wondering if you're off grid, why you're coming home and you've got less power than you thought you should have, maybe get yourself one of those meters and start testing a few things around the house. So we'll turn that on. Okay, what does that increase it? Maybe yes, maybe no. Okay, and if we select hot pot, and that says it's given us 1800 watts. And we can see down there we've got 7 watts, and it says E1, which is an error message, and that's because it can't detect a load. Sometimes with the appropriate load you can just turn the load on and it may register, and in this case we need to use a pot. So I'll just put that pot there long enough just for it to engage. Now we take the pot away. Now it says we've got 1800 watts there. The kettle's working. Shouldn't get that phone too close to that. That's the other thing, don't take devices near this when that's functioning, because yeah, although that doesn't get hot, what are we looking at there? 22 degrees. Yeah, so that doesn't get hot, and the table's 20. But it does have a large radioactive field. Like if I grab one of my coils with an LED, I could hold it probably 15-20 centimeters off the deck, and that will be lit up. So that's functioning there. And how many watts does that consume? 1039. Kettle's still running. It says it's consuming 1800, but we can see that that's not true. Well, that's just the 1800 setting, so it's not necessarily saying that. If we take that down, well, now that the kettle's just about to switch off, and this is what will happen, like if you were to use this system, it's pretty safe. It'll just, when the kettle's done, the kettle will switch off normally, and then this induction cooker will begin to flash the E1 sign. Go on, make a liar out of me. Okay, make a liar out of me. Alright, well the other kettle turns off by itself. Maybe this one doesn't. This is the wife's kettle. So, rather than kill it, I'm turning it off. But there you go, that's boil the water. And now we get the E1 message. On my older, cheaper kettle that I bought purely for experiments, it used to turn itself off, so I'm not sure what that one is doing there. But yeah, if I wanted to start that up again, press the kettle switch down and bring the pot back in. But you just got to remember to take that pot off, otherwise it'll start to heat the coil up. So it's completely safe. Let's take it down to 1000 watts. And it's still pulling the same there. If we drop below 1,000, we'll see what happens. 600. It says it's still pulling 1,000. Oh, okay, kettle's struggling to operate though. I just noticed. So take it back to 1,000. Put the pot back on. Here we go, 1,000. Yep, she's pulling 1,020. Kettle's working. It's really hard to get steam on the screen, but anyway, that gives you some idea. What's the temperature here? 27. Went up a little bit, and that's probably because I put my I left the pot on there a little too long. But yeah, all right, on to the next bit. So with this test, I'm going to be showing you a heating element that I got from a convection oven, and just to demonstrate that a lot of power can be used here and how it's different to what we're used to, is this tiny thin gauged yellow cable here that I burnt out on other experiments is damaged there. You might be able to see if I can get the camera to focus. And the point I'm trying to make here is that there's an intense amount of heat being generated in this element for a very small amount of power usage, but at the same time it's going through these incredibly thin, fragile, almost broken wires. So, you know, now I've seen one of my viewers has used pancake coils after watching a different video of mine, and he demonstrates that you can actually touch the terminals of these things whilst they're running. Now, whilst I am aware of that, and I still don't feel 100% safe doing that sort of thing, because it is just a resistance factor, and if your body has the correct chemical composition, i.e. the salts that reside in your body, and the other chemicals, if they meet the correct resonant resistance, you may find the body will be engaged. Typically this electricity seems to go not enter into the body and travel over the skin, and doesn't actually electrocute you because it can't get into the body because of the incorrect frequency. However, if you were to change that, by even simple things as manipulating your diet, you could be lighting yourself up. So we're pulling 2 watts through the meter, and I got a little temperature probe. It says that the coil in the center there is only 24. Now this is a slightly smaller coil than the one for the kettle, and that's because it was the first coil I made, and when I got this induction cooker, so I made the coil based off of the size there, but that's an indicator for the pot, where the pot's supposed to be positioned. So depending on the load, you will need to start this. So by that, what I mean is trigger. There's a magnetic induction switch in there. If it doesn't sense a significant load at the start, it will not allow startup. So in that case, what we'll do is we'll put this little pot of water on there just to trigger it. I won't leave it on there because that'll then heat up the pot, and then the coil will heat up. Whereas you see with this operation, the coil itself won't heat up. So again, I'll show that once that's in operation. I'm not going to be able to run this for very long because this heating element here will get extremely hot, and I'm just holding it with two upside down coffee mugs, which is not exactly practical and could break the handles if that gets too hot. So I'm literally going to turn that off like within 10 seconds of starting it. But just to give you an idea, there is a considerable amount of power there, and it's a very, very efficient system. So we turn it back on. We will choose the hot pot. It tells us, it's selected there, 1800 watts. We can see the E1 error. That's the system not detecting any magnetic load there that it would normally find in the base of the pot. The wattage is bouncing around about the 7 watt mark, and so that won't engage now until I place the pot on. And if I'm quiet, you might be able to hear it engaging. And we'll take that off straight away, and then we have a look at our heating element. Didn't engage it for long enough. Let's do that again. Did we get it that time? No, I might have a connection issue with one of these wires here. Let's try again. Yeah, okay, so it's going to make an ass out of me, so I must have had a connection issue, but we can see there that gets bloody hot. And what's our wattage? 828. So again, okay, so let's check the thermal temperature of the coil. Only 25 degrees, and the temperature of the element, I saw 200 and something there. You got to get that laser right on, and unfortunately you can't see where the laser dot is. So alright, I'm going to turn that off because I can smell things cooking. I'll turn it back on just to show you what the voltage is at that time when it's under load. So we'll ignite it back up using the metal pot, and we'll go AC. .205 volts, and the reason why I made a bigger coil after this one, I'll turn that off because we're going to cook stuff. Excuse me. Yeah, the reason why I made a bigger coil after that one was for an increased voltage. So yeah, these things, these induction cookers, in my opinion, are a gem that's been relegated to a simple man's task of cooking. This is a Tesla invention. Inside that induction cooker is just another pancake coil. Yeah, so the brilliance, another Tesla invention. So, you can buy yourself a ZVS switching unit. Ironically, these things are only $50. Well, it was $50 Australian. I imagine in some parts of the world you'll get them even cheaper. But the main thing to consider here is the reduced wattage, and you'd have to do a comparison run like we did with the kettle, and over time. But the main focus for this device for me was allowing me to use it off grid. allowing me to run things like a kettle or things that would be normally massive loads for a battery, and in essence just reducing the amount of wattage that you're pulling from the battery to achieve the same job. You know, it's in some cases it's better, even if it took longer, which I do believe it does for the kettle, to run off of this system comparative to the mains. But even if it took longer, you still, you know, it's an important thing when you're off grid that you don't pull as much at one particular time. So a longer duration run with a lower wattage is better than a higher wattage with a short run. It's just not healthy for the batteries nor for the inverter just to taking massive amounts of power out like that in such a short time. That longer power curve is a much better way to go. When you're finished boiling the kettle, just make sure you allow the system to run until that fan cuts out. That fan's just making sure everything inside is cooled down before it loses power. So yeah, don't just go. When you switch it off here, that's fine, but it's got this little flashing light and a timer and a thermal sensor inside to switch it off. This is why it's just a much better idea to get one of these as opposed to trying to build your own from scratch. You've got 90% of the thing here, and then, you know, if you decide that you don't want to investigate this any further, then you have a cooking device, which is great. Alright, so it's finished, it's cooled it off. We're now back to consuming the standby 2 watts. So thanks again for watching. Please like, share and subscribe.